Hello everyone, I'm building a house myself and working on the warm shell. Building the frame isn't enough, you also need to add utilities. Today I'll talk about the sewage system, about how you shouldn't make a septic tank, how Eurocubes behave, and how I would do it. For the second time, or rather, already the third. Everyone still remembers my life motto, stupidity and courage. Make yourselves comfortable because in this video there will be a lot of courage and even more stupidity. For your convenience, there are timestamps in the video, but I recommend watching the whole thing. What sewage options did I consider? A proper local treatment facility for a house for 4 people costs from 100,000 rubles, and that's without installation and discharge of treated water. Add to that the fact that they also need electricity for the compressor. The treatment plant needs maintenance and care, and often things can go wrong with it. It can even start to smell. The total amount of money and effort ends up being quite significant. An alternative could be a time-tested solution using concrete rings, 2 sealed wells with a bottom and 1 without. But doing this alone with your own hands is almost impossible, and a septic tank made of concrete rings, including the labor, would have cost me 80,000 rubles. Plus, personally, I can't do this kind of work myself. Without damaging the trees around the perimeter of the plot, a simpler option is ready-made plastic septic tanks. Money-wise, this solution would still cost me the same 80,000 rubles but without damaging the trees, and in general you always need to consider the features of your plot, since everyone's will be different. There are 3 problems with plastic septic tanks. They float up, they get crushed, or they get pushed out. The first issue can be addressed by managing the water level, ensuring the air volume in the septic tank doesn't exceed the structure's weight. Ships float by displacing more water than they weigh, but for a septic tank, the opposite should occur. The second and third problems can be solved by using insulation, for example, with Penoplex. Regular foam plastic won't work. You need extruded foam because Penoplex is resistant to environmental effects and doesn't lose its insulating properties when exposed to water. We insulate the septic tank perimeter with Penoplex like an insulated blind area, reducing frost heaving and preventing the tank from being crushed. And the last option is simply a cesspit. The vast majority of the plots around me are done this way. Just a single well made of rings or even tires without a bottom is buried, and that's it. In our region, for now, this is still allowed, but they're cracking down on it, and it's already not legal everywhere. The fines are still small, but the situation is getting stricter. A very simplified, basic explanation of how a treatment facility works. There's the first well or the first chamber, where the wastewater from the house comes in. This tank has a bottom and doesn't leak. Nothing seeps out of this tank. In the case of a septic tank, an anaerobic process takes place, meaning decomposition happens without oxygen. In treatment plants, an aerobic process occurs. They have a compressor to supply oxygen. In both septic tanks and treatment plants, organic matter turns into sludge, which can overflow into the second chamber. This chamber also has a bottom and doesn't leak. The overflow is done roughly from the center of the first tank, because all the solid particles from the house either settle to the bottom or float on the surface. There's nothing with a density that would keep it in the middle of the tank. Accordingly, all the decomposition of solid particles happens in the first chamber. The so-called grey water flows into the second chamber, where it is cleaned according to the same principle, and then, through overflow, it goes into the third tank. The third tank can be bottomless and perforated. To disperse the treated effluent into the ground, an alternative to the third tank can be a filtration field, which is a perforated pipe in geotextile placed in a trench filled with gravel. For local treatment plants, you also need to plan where to discharge the treated effluent. The effluent from a local treatment plant is cleaner, and it can often simply be discharged into a drainage channel around the perimeter of the site. But this is not possible in 100% of cases. Sometimes the same approach as with septic tanks is used. It doesn't matter what our chambers are made of, concrete, plastic, or metal. The main thing is the operating principle. If you understand how it works, you can even build a local treatment plant yourself. I didn't have 80,000 for a ready-made septic tank. I decided to outsmart the system and do everything myself. After reading some manuals, I came across a solution using Eurocubes because it's the perfect option, and I started working on it. You can buy the cubes themselves for as little as 3,000 rubles each, but then the question of transportation comes up. I found an offer that suited me, 10,000 for 2 Eurocubes with delivery and unloading included. To avoid damaging trees while burying the cubes, I chose a mini excavator over a large one. The operator and I found it amusing. My subscribers know how I feel about shovels. I'd rather dig with a shovel than eat bread, and I spend more time with it than with my girlfriend. It's time to give it a name, so here's a contest. Come up with a name for the shovel and write it in the comments. The excavator operator and I had a good laugh about it. He was like, yeah.
Just use the shovel, like, you reinforced it with the shovel, yeah, just use the shovel. This excavator is getting on my nerves already, let me dig with the excavator.
He was like, no, I'll dig with the shovel. Nothing went according to plan here. For the first time on my site, the groundwater level is very high, about half a meter from the surface, which makes the work much more difficult. I had a banana plan. This summer was unusually hot and the water level dropped to almost 2 meters. At that time, I ordered an excavator. According to the plan, the excavator was supposed to easily dig the pit, install the cubes, and then go do work in another corner of the site. At that time, I would have made the overflows and buried everything immediately, but excavators are always booked, so I had to wait. And just a couple of days before the scheduled date, it started raining, and in those few days, so much water accumulated that it was filled to the brim. There was also supposed to be a filtration well after the 2 Eurocubes to drain the treated wastewater, but they weren't available in stores at that time. And on top of everything, the excavator broke down in the middle of the work, and to make matters worse, it was raining during the job, so I just gave up and left everything as it was. The cubes have the same problems as factory-made plastic septic tanks, only even worse. Eurocubes are not designed to be buried in the ground, and they handle external pressure extremely poorly. When filled with water, they can barely manage, but they won't survive frost heaving. I plan to fix this by insulating the septic tank around the perimeter for 1 meter outward using foam board laid across. Eurocubes need reinforcement to prevent crushing by soil. Using corrugated sheet metal like this works best. I used old doors instead. They're painted and wouldn't rot anytime soon. The thing is, the reinforcement has to fit tightly against the frame, otherwise it makes no sense at all. All my creative improvisation ended in failure. When I saw the next day that both Eurocubes were completely underwater, I realized we overdid it with the excavator and buried the cubes too deep, because you can see how much it sank after the rain. About 10 centimeters more disappeared, and this one is just barely above the surface. We had a week of rain, and the groundwater reached its highest level. That means it doesn't get any higher than this here, there's just nowhere for it to go. And the sewage outlet is never underwater, so it will always be above. And this tank also needs to be raised, so there will always be an air gap for ventilation, and water will always drain there. Let's go back a bit to the theory. With a high groundwater table, it's generally not recommended to install a septic tank at all. But in reality, if the groundwater is always at least a little bit lower than the last overflow, the system will work. Yes, it will even work underwater, but then there's a high chance of clogging in the pipe. Plus, to prevent the septic tank from smelling, you need ventilation, and that also won't work underwater unless it's above the second overflow. That's why the solution needs to be viable. The tanks needed to be lifted, especially the second one. At first I wanted to do it manually, so I pumped all the water out of the pit with a drainage pump. That's the downside of the tanks, because there weren't any dents along the edge before, nothing had affected it. It was standing there completely filled with water, underwater, and the walls got dented. Actually, you can see them straighten out right before your eyes. So there was water pressure on it, the water just crushed it completely, you can see it, there's a huge dent, and it was just the water pushing it in, even though it was also completely filled with water itself. And it really gets dented by everything. Damn, everything dents it, and now nothing is really pressing on it. Even if you put some kind of reinforcement there, sand still gets in, even between the grate and the plastic itself. And look how it got crushed when the water drained away. And to drain the water from this cube, you had to open the tap. I easily opened the tap on this cube, but on that cube the tap got buried by a mud flow on that side and I had to dig it out. That's how it goes, it's almost up to the chest basically. I barely managed to dig it out there and it only opened halfway, basically what a mess. And the pump keeps running. All of this is just in a stream. I can feel the pebbles flying through the hose, the valve. I was glad that it was pumping in a stream. Because the hose was almost halfway clogged with quicksand, the pump was pulling in the quicksand and it started pumping, but it didn't go through the hose. Of course, it started pouring rain even though I specifically chose a day with no rain in the forecast, just to fix the septic tank. Draining the tank with its own faucet didn't work. The faucet kept clogging with quicksand so the water wouldn't drain. I had to use a jigsaw to cut a hole in the tank for the drainage pump and pump the water out of the tank, but lifting the tank by hand turned out to be impossible. The tank frame was pulled into the quicksand and stuck permanently. Then I had to get creative. Every other comment under the videos about Eurocubes says that they float up, so I decided to do it on purpose. I left the tank empty and went to take a break. Imagine my surprise when the Eurocubes didn't float up, but just got crushed instead. In the end, the cubes were ruined and buried in the quicksand. I had to find a way out of the situation. I tried to live by the principle that my universe takes care of me, so I didn't get too upset. Whoever gets sad will bloom. It's better to have a small fiasco with the cubes now than to mess up big time later. After I started using the sewage system and searched through construction supply websites, I found conical drainage wells. But trouble was waiting for me here too. They're always waiting for me, these troubles. It's a social experiment. Write your thoughts in the comments. What would you think if you saw two products on a website? One drainage well with perforation and the other drainage well without perforation. I'm quoting the product names. Personally, I thought that the second well, the one without holes, shouldn't leak, but that wasn't the case. The well without perforation actually had perforation. That's the first thing. Secondly, on the website, the description said that the bottom of the well is 1 meter, but in reality, it turned out to be 772 millimeters. When I got the goods, I didn't notice this, signed everything, so any claims against the store wouldn't be justified. It was my own fault, and basically I couldn't think of anything smarter than to buy sealant and cover up all those perforations. I used up 15 tubes of sealant, spent a whole workday, but the job got done. I bought covers for the wells, but couldn't find any bottoms for sale. After advice and some thought, I decided to install them without bottoms and concrete the bottom later. But to install the wells, I had to get rid of the cubes. I unscrewed the top part of the frame and I used a jigsaw to cut out the top of the cube, and miraculously, the well's bottom was right in my hands. I had been racking my brain trying to figure out what to make it from. The cube got crushed like this, but it didn't seem to lose its seal. It's dented but not leaking. To set the well at the right height, I added a bit of sand to the bottom of the Eurocube and then put the improvised well bottom in there. I didn't have a lid for the first cube, so I made a plug out of foam board and secured it with some foam for extra confidence. I also attached the bottom to the well using foam, both inside and outside. It wasn't watertight on the first try. I located the water leaks in the well and added more foam. I installed the second well the same way in the second Eurocube. For its bottom, I used the original lid from the cube. The third filtration well was supposed to be without a bottom. I just placed it directly on the sand. I had to dig a little because that spot was really silted up. It was in this kind of sludge. You have to work when you have quicksand, and this happens even when you're digging with an excavator. Because the water comes in so fast that even Minnick could barely manage to dig. Since the water comes in and everything collapses, he could barely keep up with the digging there. And the excavator operator said that you have to be very careful, just like how I'm standing right now, very careful. If it were deeper, because all of this gets eroded, you can see here that it's washed out way over there, far away. It gets eroded and collapses. There was a case with an excavator operator. He was digging, then moved to another spot. While they were burying a septic tank, another guy started working with a shovel on the overflow as the excavator worked elsewhere. In the end, he wanted to ask something there. The man needed to come over, but everything had collapsed there, and the man was buried up to his neck, and he already had foam coming out of his mouth. That is, he was buried, he couldn't breathe in, the weight of the soil was heavy, he couldn't even take a breath, and he already had foam coming out of his mouth. He was already there. Well, he dug him out right there with an excavator, uncovered him, and it seems the man is okay, alive and well. Well, anyway, keep in mind, be very careful, because dealing with these quicksands is just a nightmare. All the wells were put in place and we could start fixing their positions, gradually covering them with soil. And Mizzy of stands mom. Next, I had to make the overflows using a laser level, mark the outlets on the wells. Each overflow had a slope of 2 cm per meter and was lower than the previous one. I drilled the holes and using transition cuffs, inserted the pipes into their designated places. I also thoroughly sealed everything with sealant and foam. And in one spot, I had the frame of a cube under the pipe, but you can't leave anything under the pipe, because our pipe is rigidly fixed in one position, and the elements under the pipe, due to frost heaving, will rise up, and as a result, they could simply crush the pipe. I made the first overflow like this to make sure that no solid particles would get into the second chamber, and the second overflow was just made from a regular T-fitting. Ideally, the third well's perforation should not have been sealed with sealant but wrapped with geotextile and surrounded by gravel instead. That way it would have had greater filtering capacity. In my case, it will only be able to drain water through the bottom, and without gravel backfill, the filtering capacity might not be enough. But ordering gravel would have been too expensive, so I decided to add a 5-meter filtration field after the third well. I had enough leftover materials for this. From a distance, the wells look reliable, but in reality they seem kind of flimsy. My soil is extremely waterlogged and experiences strong frost heaving, plus the wells are only buried 1 meter deep. That's why I decided to insulate the entire perimeter of the wells with foam board to be completely sure the septic system stays safe. Yes, this foam board contour, similar to the insulated blind area around the house, is 100% effective. It won't eliminate frost heaving, but the ground will freeze much less and to a much shallower depth. As a result, less soil will freeze, and the force of frost heaving will be significantly reduced. One of the problems with buried tanks is that even if they aren't crushed by frost heaving, they can still be pushed up out of the ground. And in the case of a septic tank, this shouldn't happen because the overflow levels could be disrupted and the system could even break. Insulating septic tanks with foam board solves this problem, and it's not only applicable to septic tanks, but to any buried containers, like caissons used for storing something with ventilation. I haven't fully figured out yet how the vent pipe should ideally be installed in the house, but as a matter of principle, I don't want to run any pipes out onto the roof. That's the plan. Arrange ventilation along the path of water flow and provide an air supply using a 50mm pipe from the first well. Just put it here in the opening, run it out past the fitting, raise the pipe about ½ meter so it doesn't get buried by snow in winter, and cover it with a cap. Right here behind the fitting, all this will be hidden neatly. Ventilation between the first and second well will be possible through the overflow because it's never completely underwater, and the overflow is between the second and third well. During heavy rains or spring snowmelt, it can fill up with water. That's why you need to install an extra ventilation pipe here. And according to the plan, the outlet should be made from the third well. Here you need to run a 110 pipe from the storm drain and then take it from the well over there to the tree about 34 meters up. I'll check how the ventilation works, and if needed, we can redo everything. I need to finish the ventilation, seal these holes near the lids and the well, and basically everything can be covered up. I'll leave the hatches open on the surface for now, and I'll figure something out with them later. For example, there's this decorative option, the sewer pipe itself. It doesn't freeze. And for some reason, everyone who came to my site pointed at this spot and asked why I buried it so shallow. And won't it freeze? First of all, when organic matter decomposes in the wells, it releases thermal energy, and even if it's just a little, it warms up the air in the pipe. And secondly, there's only air in the pipe. There shouldn't be any water there. The pipe shouldn't be filled with water. The water should flow through the pipe into the tank. So what is there in the pipe to freeze? But in reality, it doesn't freeze, only in theory. Let me remind you, I have 20 years experience living in private houses, including my previous one. The sewer pipe used to freeze, but it was metal, and I'm not sure it was installed correctly in terms of slope. The sewage would freeze during periods of least use. So, the exact reason is unknown, but I think that when little water flowed through the pipe, it gradually froze and built up on the metal pipe. This shouldn't happen with a plastic pipe. So, let's check how the sewage system was set up in the previous house. My father made a formwork out of metal and manually poured a concrete ring. You can also make it square, that's easier, it doesn't have to be a ring. Then he would get inside the ring and dig out the soil inside the ring with a shovel. The ring would settle into the ground under its own weight. After that, he would put the formwork on top of this ring again and pour the next one. And that's how he made a well about 2 meters deep and about 1.5 meters in diameter. The well didn't have a bottom, and everything from the house flowed into this single well. Over time, because of the waste, the bottom gets silted up and loses its filtering ability, so the water can't go into the ground. Then the well fills up and everything overflows from the top. We would catch that moment and call the sewage truck, not understanding people who panic like, oh God, we need to pump out the sewage. No, we're all gonna die. The issue is solved with one phone call and 1,500 rubles. I live in a village with a population of 10,000 and we have 3 companies that handle pumping. I don't see what's so difficult about it. There were 4 of us living in the house, and in 20 years we pumped it out maybe 5 times. Same with my septic tank too. Maybe sometimes you'll have to call a truck, because there will always be at least a little bit of non-degradable waste being flushed, like sand from sneakers. For example, the first well might fill up, but that's very rare. And let's do the math. With my fiasco with the cubes, I spent about 40,000. Without the fiasco, it would have been 30,000. Loss, which is a real pain to operate, even if it costs 100,000 rubles, with installation it could easily come out to 150. So even if you have to call the truck once a year, how many years would it take to pay off this loss? And in practice, I already know that I'll need to call the truck less than once a year. So a proper septic tank is quite a reasonable solution. I don't recommend using Eurocubes for a septic tank. Yes, you can reinforce them from the sides, you can insulate them with foam board, but still there's no guarantee that they'll stay intact. When in use, filtration conical wells can only be used if they have no perforation, are at least 1.5 meters deep, and have a proper bottom. I haven't found any like that here. If you know where such things are sold, then that's a workable solution. But I had another idea come to mind. There are pipes like these, SN8 or SN6, like the ones I bought for the driveway to the plot or for drainage wells. They come in diameters of 575 by 500 and there are lids for them. You can buy a 6-meter pipe and 5 lids, cut the pipe into 3 parts, use 2 lids and seal them as the bottom. And voila, you get 3 very sturdy tanks with enough capacity for 4 people. In terms of cost, it won't be much more expensive than what I did. The main thing is to install all of this in one day. As soon as you dig the pit, there shouldn't be any water in it at the time of installation, and the bottom of the pit needs to be leveled to the right mark right away. Then, installing the septic tank will be easy and straightforward. If you still have questions, feel free to ask in the comments. Subscribe to the channel so you don't miss the next video about the continuation of the house construction. Wishing everyone well and see you next time.